Okay, in this video I'd like to give you a little bit more help on the homework number 4, and we're looking at problem 2 here. Well, first of all, problem 1. Problem 1 is asking you to make a sketch of the switch. I'd like you to do that along the lines of the sketches I've made in previous videos. It asks you how many simultaneous connections can be handled by the switch. That is obtained by counting the number of paths through the switch fabric. So if you sliced the switch along this line here, how many lines would go through it? Alternatively, it's the number of outputs. It's either the number of outputs of the total number of outputs in stage 1, or the total number of inputs of stage 2, or the total number of outputs of stage 2, or the total number of inputs of stage 3. And then it asks you whether or not the switch is blocking, rearrangeably non-blocking, or strict sense non-blocking. And I gave you the criteria for all of those in a previous video, so you can look at these criteria and ask you, given the little n and the k, by comparing little n and k, you can tell which type of switch it is. And then finally, in this same video here, previous video, I showed you an example of a blocking configuration. If you make a simple switch design and set up a few paths, it's very easy to find an example of a blocking situation where you show some paths that are through it and then ask yourself for one more path, and you can see that it can't be done. Okay, so that's how you do problem number 1. In problem number 2, we've got these two tables for a bunch of switch designs, and the parts A and B ask you to write down the formulas. Part A is just the formula for the M column here. Okay, and I gave that in a previous video. That's just the total number of 2x2 elements in the switch design given big N, little n, and little k. Okay, part B asks you for the formula for the non-blocking design. Well, each of the rows in these tables represents a single switch design. Okay, a given n, big N, little n, and k. Okay, so these first three numbers give a switch design. The next column is simply the ratio of little k to n, and the fifth column is capital M, the number of switching elements in that design. Okay, and for reference, what we're showing here in column 6 is the strict sense non-blocking M value. That is the case where little k is 2 times little n minus 1. Okay, and so this non-blocking M is just as a reference. Okay, finally, capital N squared is the number of 2x2 switches in the full matrix, what we call the full matrix, the full square array or rectangular array. And finally, the ratio, this is supposed to be capital N squared divided by M. This is the ratio of the full matrix to the switch design that we've got in the row. Okay, and so you can see here 6.4 is 16,384 divided by 2560. Okay, so that's how you make these tables. You're basically plugging into the equations. And then it asks you here, so you're supposed to make that spreadsheet and drop it in the Dropbox that I gave in Angel. And then it asks, what are the blocking probabilities for both of these cases? Well, the hint is that this first table is for class 5 switch designs, and the second one is for tandem switch designs. And if you'll recall, I came up with a formula for the blocking probability, and you will notice that these two tables are in fact taken from the notes, and so the blocking probabilities are given there. Okay, and I will use a different video to talk about those blocking probabilities in more detail. Let's see. Problem 3 is a TST switch design. I'll talk about that in a separate video. Problem 4 is another 3-stage Kloss fabric. This should be straightforward after everything we've done so far. And then finally, the rest of this page is page 2, problems 5 through 8 are on blocking probabilities, and I'll deal with them in a later video as well. Thanks.